Okay. All right, so what are we going to do with these three numbers? Add them?
Yeah.
Is that what it was? This is the molar mass. This should be a review, correct? All right, so that's step one. Step two, divide the total mass of each element by the molar mass. What do I mean by the total mass? Well, I only have one K, and its total mass then is still 39, right? I have one Mn, so its total mass is still 54.94. But I have 4 oxygens, so is its total mass 16 or is its total mass 64? 64. So here's the easiest way to show your work for these is to just put a division sign right here and take that molar mass and put it on the bottom. Then step 3 says multiply it times what? 100, because we want to make it a percentage.
So you're dividing all of those by molar mass and then times it.
Yep. All right. Briley, will you do potassium? Ian, will you do manganese? Do you have a calculator, Ian? No? All right. And Haley, will you do oxygen? Do you have a calculator? Yeah? Okay. The rest of you can still do it. How many sig figs are in 39.09?
4.
And how many are in 158.03?
5.
5. So are we going to keep 4 or 5? 4.
Why are you times by 100?
To make it a percentage.
Oh, okay.
It's kind of like if I had 50 out of 100, that'd be 0.5, but that's 50%.
Yeah.
Okay? All right. Riley, what do we get?
24.74.
And that's the percent potassium in this compound, right? All right.
34.77.
And that's the percent. The unit would be percent manganese. All right. What do you got?
0.449.
Did you multiply it times 100?
Oh, no.
Okay.
If you have like 3 sig figs and when you get your answer it only has 2, you have to make it more.
Yeah, 0.0 or whatever.
40.50.
40.50. Now, a good way to check this is to add them up. What should they add up to? 100. Now, because of sig figs, will they always add up exactly to 100? No. But if you add them up and they make 127, you did it wrong. If you add them up and they add up to 61, you did it wrong. But if you get 99.97 or 90 or 100.02, you probably did it right.
100.01.
You got 100.01? Sounds good. So again, that just means a couple times we had to round up.
What if you get like 98 or something?
98, you might want to go back and see if you picked the right one. Like if you took,
The right sig figs.
or the right, if you took this number or this number.
Oh.
Couldn't you also do 100 divided by 158.03 times by 54.9?
Wait, what?
For the second one, couldn't you do it like that?
This?
100 divided by the middle number and then times the first one?
100 divided by this?
Yeah, and times by.
Yeah, I mean, it's just, you're essentially, you have this. So you're saying, could you start with this divided by that times that?
Yeah.
Yeah, it's the same thing.
Okay.
I mean, I wouldn't, it doesn't make sense, but it's okay. It doesn't matter. All right. First one. Okay, let's look at the second one. calculate the percent composition of all elements in lead 4 chromates. So let's go ahead and recreate our molar mass in case there's anybody who forgot. TJ, how many lead are in this? One lead. Now it's, hold on, let me move it back up because it's, all right. Is that too small? Can we read it? All right. Yolanda, how many chromiums are in this compound? Two.
Oh, what?
Good job.
I never knew that.
All right, Dylan, how many oxygens are in this? 8. All right, Vincent, will you look up lead? Jordan, will you look up chromium? Does anyone need to look up oxygen? Please tell me no. All right, Vincent, what do you got?
207.20.
So what do you do when you get your oxygen and it's 128? How do you make that?
0.00.
So you, but wouldn't that be too many sick things?
Yeah, but we're adding them all together, so it goes by the place value rule, which I haven't taught you for addition and subtraction, but it's different. Just trust me. Just keep all your molar masses 2 places after the decimal, and we'll be good. What do you got?
51.10.
51.10?
Yeah.
Is that what everyone else has for chromium? All right. What are we going to do? Multiply these. I got 1 lead, so 207.20. What do I get when I take 2 times 51.10? I get 102.20.
Yeah.
And 8 times 16.00, I get 128.00. All right, Deshaun, what am I going to do with these 3 numbers now? Add them up. And that number that we get is called the what? Molar mass.
And it's 437.40.
All right. Good? All right, Brent, what are we going to do to get the percent composition?
Divide them all by
158.
158. 437.
All right. And then you said do what?
Multiply by 100.
How many ones are in the 100?
Can you just write that straight into your calculator? Like that? How you have it?
Yeah, 207.20 divided by 437.40 times 100. Yep.
Okay, so
All right, Sarah, can you do lead? Deshaun, will you do chromium? And Abigail, will you do oxygen? Everyone agree these are easy?
yeah. Do we have to write this workout on our papers?
Yep.
47.37.
And that's the percent lead, right? All right. Who's got the percent chromium? Who did I have? Deshaun? Were you percent chromium?
Yeah.
What'd you get?
23.36.
Our
37 around.
3.7? Can't erase my pen, can I? And who was the last one? All right, what'd you get?
I got 29.26.
20 what?
29.26%.
Okay. So this goes to show you, this is a very good thing to understand about mass, because do you see that at first glance you have 8 oxygens, 2 chromiums, and 1 lead? You might think that a lot of lead 2 chromate or lead 4 chromate, excuse me, is oxygen, right? There's 8 of them. You might think that a lot of the mass is due to the oxygen, but only what? 29% of it. Almost half of the mass is due to lead. It's a heavy metal, right? All right.
Are we doing the lab tomorrow?
Pardon me?
We're doing the lab tomorrow.
Okay, so let's go ahead. And number 3 says calculate the percent composition of just oxygen and compare it versus the percentage of oxygen in the previous 2 compounds. So in KMNO4, we said there was what? 40.50?
Wait,
And in lead 4 chromate,
it's 29.26.
29.26% oxygen. All right, so let's go ahead and do the magnesium hydroxide.
Wait, I thought we only had to do oxygen.
We do, but I'm just saying for magnesium hydroxide.
Oh, but
Do you guys yesterday, or not yesterday, on Monday you already did the molar mass, right?
but do we have to do the whole thing, or do you? Just,
No, not in this case, because you already have it, right?
Wait, do you have to know the molar mass to do that?
Yes, but you already did it. So turn to the front. TJ, what do you have is the total mass due to oxygen in the magnesium hydroxide?
I don't have that written down.
Huh. Hmm.
I have 58.38.
That's the molar mass. What's the total mass due to oxygen?
Is it 32?
What would it be?
Is it 32?
0.00, right?
Okay, I did have it written down. I didn't think I
So
was
O2 equals
32.00 divided by, now you just told me what's the molar mass? 50 what? 0.30? 33
3
times what?
100.
100. All right. Who's got that? Yolanda?
54.86.
What does it mean? Compare it to the other ones.
Well, look at this. Do you see in the first one you have 4 oxygens? The second one you had 8 oxygens, and the last one you only had 2.
Yeah.
But of the total mass, the one that had the least number of oxygens actually had the greatest oxygen percent by mass.
Yeah, I get that, but do
Okay.
you want us to like write
Just
that
say it
out?
had the most.
Okay. I didn't know if you just wanted
To
us
compare,
write
you
that
just say who's the most, who's the least, who's more of the, whatever is.
out. So the least amount of oxygen had the most amount of mass.
Yeah. Or you could just say the percent oxygen and MgOH taken twice was the largest percentage.
I think I'm
Okay, that's fine. Any questions on this? Okay, so I'm going to let you go ahead and